Green gram or moong, Vigna radiata, is a leguminous pulse crop grown all over India as a protein-rich dal. Phaseolus radiata is the synonym of Vigna radiata, which belongs to the family Fabaceae and has diploid 2n chromosome number 22. Many botanists agree that it originated in India, since its closely related species like Vigna radiata variety Sun lobata grows wild in India, and it has been grown in this region since prehistoric period. Mature mung bean seeds or flour enter a variety of dishes such as soups, porridge, snacks, bread, noodles, and even ice cream. Split seeds are eaten, fried, and salted as a snack. The seeds may also be parched and ground into flour after removing the seed coat. The flour is used in various Indian and Chinese dishes. The flour may be further processed into highly valued starch noodles, bread, biscuits, vegetable cheese, and extract for the soap industry. Sprouted mung bean seeds are eaten raw as salad or cooked as a vegetable. Being a short duration crop, it also provides an excellent green fodder to the animals. It fits well in the various multiple and intercropping systems. After picking of pods, mung bean plants may be used as green fodder or can be incorporated as green manure. Vernacular names. Green gram is also known as mung or golden gram. In South Indian languages, it is known as pasipayaru or pachai payaru in Tamil, hesaru kalu in Kannada, pesara in Telugu, and cheru payaru in Malayalam. Origin. Archaeological explorations have obtained mung beans in many sites in India. Areas with early finds include the eastern zone of the Harappan civilization in Punjab and Haryana, where finds date back to about 4,500 years, and South India in the modern state of Karnataka, where finds date back more than 4,000 years. Some scholars therefore infer two separate domestications in the northwest and south of India. In South India, there is evidence for evolution of larger seeded mung beans 3,500 to 3,000 years ago. By about 3,500 years ago, mung bean were widely cultivated throughout India. Cultivated mung beans later spread from India to China and Southeast Asia. Archaeobotanical research at the site of Khao Sam Keyo in southern Thailand indicates that mung bean had arrived in Thailand by at least 2,200 years ago. Finds on Pemba Island indicate that during the era of Swahili trade in the 9th or 10th century, mung bean also came to be cultivated in Africa. Geographic distribution. It is grown mostly in Asian region traditionally, while its cultivation has spread to Africa and America relatively in the recent times. Green gram is cultivated in India, Burma, Ceylon, Pakistan, China, Fiji, and Africa. More than 70% of world's green gram production comes from India. India is the world's largest producer as well as consumer of green gram. It produces about 1.5 to 2 million tons of mung annually from about 3 to 4 million hectares of area with an average productivity of 500 kg per hectare. Green gram output accounts for about 10 to 12% of total pulse production in the country. Mung production in the country is largely concentrated in 5 states, namely Rajasthan, Maharashtra, Andhra Pradesh, Gujarat and Bihar. These 5 states together contribute for about 70% of total mung production in the country. But there is a significant rise in production from other states in recent years, particularly from Tamil Nadu, Uttar Pradesh and Gujarat. Nevertheless, production remained volatile across the years with respect to most of the states. Rajasthan, Maharashtra occupies the first 2 positions, contributing over 45%. Andhra Pradesh contributes about 10%, while together Gujarat and Bihar account for about 13% of total production in the country. Major spot markets are in central India, Mumbai, Jalna, Latur, Akola, Indore, Paparia, Harda. In northern India, Delhi, Kanpur, Lalitpur and Jhansi. In southern India, Tandur, Gulbarga, Yadgir, Bidar, Raichur, Sedam and Chennai. Economic importance. Green gram is a rich source of high quality protein. It contains about 24% protein. It contains amino acids such as arginine, histidine, lysine, tryptophan, etc. It is a good source of calcium, iron and phosphorus. It is rich in vitamins, thiamine, riboflavin and niacin. It has high digestibility and palatability. In human food, its parts are used as green vegetable. Its whole grain and split grains are used as dal and curry. Being highly digestible, its curry is generally recommended for patients. Its flour is used in various preparations like halwa, savory dishes, snacks, pakoras and fried dal to get very delicious and nutritious products. Its green plants, chopped and mixed with other fodder, are palatable feed for animals. It is also used as green manuring crop, which adds nitrogen in addition to humus to the soil. It is a soil protecting crop in rainy season. Mung bean is a leguminous crop. It has the capacity to fix atmospheric nitrogen through symbiotic nitrogen fixation. It is also used as green manure crop. Soil and climatic requirement. Soil. It is cultivated on a variety of soils, from red laterite soil in South India to black tartan soil in North India and sandy soil in Rajasthan. It tolerates a wide range of pH, but the most favorable range is pH 5 to 7. To cultivate green gram, a well-drained loamy to sandy loamy soil is the best, while saline and alkaline soil or waterlogged soil are not at all suitable for cultivation. Climate. Suitable climate for cultivation of green gram is the warm, humid and within temperature range of 25 to 35 degrees Celsius with modern rains of 80 to 100 centimeter well distributed during growing period of 100 days. Mung grows well from sea level to as high as 2000 meters above mean sea level. Normally, middle of March to last week of June is suitable season as high temperature and low humidity keep insects and disease infestations at their lowest. In North India, it is cultivated during warm and wet Kharif season and in South India in midwinter season. Varieties: morphology of mung bean. Mung bean belongs to the family Fabaceae. It is an erect or suberect, deep-rooted, much-branched, tomentose annual herb with the height ranging from 30 to 130 cm. Leaves are alternate, trifoliate, petals are long, stipulates, ovate, leaflets ovate up to 12 into 10 cm. Flowers are axillary, racemose, peduncle up to 13 cm in length with cluster of 10 to 12 flowers. Corolla yellow in color, sometimes curved, 5 to 10 cm long. Number of seeds per pod ranges from 10 to 15. Seeds are oblong, green or olive green in color, sometimes yellow, brown or blackish also. The state-wise recommended varieties of green gram: Andhra Pradesh and Telangana. Pusa Baisakhi PDP 711, PS 16, ML 131, T44, Kondavidu CGG 127, Kopargaon Lam M2, PS 7, PS 10, K851. Assam T44, Kopargaon, PS 16, K851, PS 7, PS 10, Pusa Baisakhi. Delhi Pusa Baisakhi, Mohini, that is S8, PS 7, PS 10, PS 16, Pusa. Bihar BR2, Sunaina, Amrit, Pusa Baisakhi, PS 16, PS 7, PS 10, T51, PDM 54 for summer and Kharif, PDM 11 for spring, Pusa Baisakhi. Gujarat Gujarat 1, Gujarat 2, Pusa 105, Sabarmati PS 16, ML 337, PDM 11, K851. Himachal Pradesh Shining Mung 1, PS 16, PS 7, PS 10, K851, Pusa Baisakhi. Haryana Varsha PS 7, PS 10, Pusa 105, Pant Mung 1, Pant Mung 3, ML 5, T44, P16, K851, G65, S9, ML 267, ML 337, Pusa Baisakhi. Jammu and Kashmir T44, Pusa Baisakhi, PS 16, PS 7, PS 10, PDM 34. Karnataka Jawahar 45, Pusa Baisakhi, PS 16, Kopargaon. Kerala CO4, Pusa Baisakhi, Mohini, that is S8. Madhya Pradesh Kargaon 1, Krishna 11, Jawahar 45, Kopargaon, Mohini, S8, PS 16, Pantmung 3, Pusa 105, ML 337, PDM 11 for spring. Maharashtra Jalgaon 781, Kopargaon, Pusa Baisakhi, PS 16, ML 131, Pusa 105, TAP 7, ML 337, PDM 11 for spring season. North-Eastern Hill Region Pusa Baisakhi, PS 16, K851, PS 7, PS 10. Orissa HY 403, HY 124, ML 131, Pusa Baisakhi, Kopargaon, PS 16, Dhauli, Ratila. Punjab ML1, ML4, G65, PS10, Pusa 105, Pant Mung 3, ML32, ML267, ML337, Pant Mung PS7. Rajasthan R2888, D6626, RS4, Jawahar 45, Mohini S8, T44, Pusa Baisakhi, PS16, Pant Mung 3, Pusa 105, ML37. Tamil Nadu CO1, CO2, CO3, CO4, KM1, ML131, KM2, ADT2, Payur 1, Pusa Baisakhi, Mohini S8, CO6, COGG7, VBN2, VBNGG3, VRMGG1, ADT3. Uttar Pradesh Type 1, Type 4, Type 51, K851, Pusa Baisakhi, PS16, PS10, PS7, Pant Mung 2, Pant Mung 3, ML267, Pusa 105, ML337, PDM 54 for summer and Kharif, PDM 11 for spring, Pant Mung. Cultural practices for main crop: field preparation, prepare the land to get fine tilth and form beds and channels. To tide over the soil surface, crusting, apply lime at the rate of 2 metric ton per hectare along with FIM at 12.5 metric ton per hectare, or composted coir pith at 12.5 metric ton per hectare to get an additional yield of about 15 to 20%. Seed rate: maintain the optimum population of 3,25,000 per hectare. The seed requirement per hectare is 20 kg for pure crop and 10 kg for mixed crop for all the strains. For rice fallow crop, 30 kg per hectare is required. Seed treatment: treat the seeds with carbendazim or thiram at 2 gram per kg of seed for 24 hours before sowing, or with tuck formulation of Trichoderma viride at 4 gram per kg of seed, or Pseudomonas fluorescens at 10 gram per kg of seed. Biocontrol agents are compatible with biofertilizers. First, treat the seeds with biocontrol agents and then with rhizobium. Fungicides and biocontrol agents are incompatible. Therefore, do not use fungicides with biocontrol agents. Treat the seeds with 1 packet, that is 200 gram per hectare of rhizobial culture CRM6 and 1 packet 200 gram per hectare of phosphobacteria, 1 packet 200 gram per hectare of PGPR developed at TNAU using rice kanji as binder. If the seed treatment is not carried out, apply 10 packets, that is 2 kg of phosphobacteria and 10 packets, that is 2 kg of PGPR with 25 kg of farmyard manure and 25 kg of soil before sowing. Fertilizer application: apply fertilizers basally before sowing. For rain-fed crops, apply 12.5 kg of N plus 25 kg of P2O5 plus 12.5 kg of K2O plus 10 kg of S per hectare. For irrigated crops, apply 25 kg N, 50 kg P2O5, 25 kg K2O plus 20 kg S per hectare. Also apply soil application of 25 kg zinc sulfate per hectare under irrigated condition, and also apply soil application of TNAO micronutrient mixture at 5 kg per hectare as enriched FIM by mixing 5 kg of micronutrient mixture with 50 kg of moist FIM and incubating for 1 month in shade. For yield improvement, through increasing the physiological, biochemical attributes, foliar spray of urea 1% on 30 and 45 days after sowing is necessary. For rice follow pulses in delta area, the recommendations of foliar spray is 2% DAP on 30 to 45 days after sowing. Sowing. Dibble the seeds adopting a spacing of 30 into 10 cm. For bund crops, dibble the seeds at 30 cm spacing. Water management. Irrigate immediately after sowing, followed by live irrigation on the third day. Irrigate at intervals of 7 to 10 days depending upon soil and climatic conditions. Flowering and pod formation stages are critical periods when irrigation is a must. Avoid water stagnation at all stages. Apply KCl at 0.5% as foliar spray during vegetative stages if there is moisture stress. Spraying of DAP, NNA and salicylic acid. Spray as foliar spray of NAA 40 mg per liter and salicylic acid 100 mg per liter once at pre-flowering and another at 15 days thereafter. This will promote flowering and seed setting. Also apply foliar spray of DAP, that is diammonium phosphate, or urea 20 grams per liter once at flowering and another at 15 days thereafter. Weed management. Pre-emergence application of pendimethalin at 3.3 liters per hectare under irrigated condition or 2.5 liters per hectare under rain-fed condition on 3 days after sowing using backpack, knapsack, rocker sprayer fitted with flat fan nozzle using 500 liters of water per hectare. After this, one hand weeding on 30 days after sowing gives weed-free environment throughout the crop period, or EPOP application of physalofop ethyl at 50 gram active ingredient per hectare and imazethapyr at 50 gram active ingredient per hectare on 15 to 20 days after sowing. If herbicide is not applied, give hand weeding on 15 and 30 days after sowing is necessary. Multiple bloom technology. A special technology being practiced in Tanjore district for black gram and green gram. The soil is alluvial and rich in organic matter and nutrients. The crop is sown during early summer, January, February, as normal crop, and fertilizer is applied as per recommendations for irrigated crop. In addition to that, top dressing of nitrogen is done with an extra dose of 25 to 30 kg through urea. Since pulses are indeterminate growth habit and continue to produce new flushes, the top dressing will be done on 40 to 45 days after sowing. The crop completes its first flushes of matured pods during 60 to 65th day and put further second new flush within 20 to 25 days. Therefore, 2 flushes of pods can be harvested at a time within the duration of 100 days. The principle behind the method is as follows. The leguminous crops are nitrogen fixers and do not need any extra nitrogen. Whatever the nitrogen is available will be used for the first flush of seeds. However, application of additional nitrogen just in appropriate time will signal the second bloom of the seed setting. Crop rotation. Green gram is a legume crop and therefore fits into crop rotation as well. Some of the important crops rotations are maize, wheat, moong, potato, moong, wheat, and potato, wheat, moong. Rice follow crops. The intensive cultivation of cropping practices with high-yielding rice varieties require better soil and nutrient management. However, the loss of soil nitrogen occurs continuously through removal of plant or harvesting of grains affects soil nutrient adversely. Soil nitrogen supply through biological nitrogen fixation, that is BNF, by associated microbial population is one of the ideal options for rejuvenation of soil fertility. In addition to the fixing atmospheric nitrogen, leguminous green manures play a significant role in conserving soil nitrates. Follow crop system has been adopted to achieve two goals. The moisture availability in the field at the end of the rice crop helps the growth of pulse crop without additional water supply. The nitrogen fixed by pulse crop will be used by the next rice crop. For the farmer, the productivity increases in both the original rice crop as well as the follow crop of leguminous pulse crop. The package of practices for rice, moong dal follow crop is as follows. Varieties. All the varieties generally recommended can be used. Seed rate 30 kg per hectare. Time of sowing 3rd week of January to 2nd week of February. Sowing of seeds. For relay cropping, broadcast the seeds in the standing crop 5 to 10 days before the harvest of the paddy crop uniformly under optimal soil moisture condition so that the seeds should get embedded in the waxy mire. For combined harvesting areas, broadcast the seeds before harvesting the paddy crop with machines. Spraying of DAP, NAA and salicylic acid. Spray as foliar spray of NAA 40 mg per liter and salicylic acid 100 mg per liter once at pre-flowering and another at 15 days after. Also spray as foliar spray of Pulse Wonder formulation by TNAU at 5 kg per hectare or DAP 20 grams per liter once at flowering and another at 15 days thereafter. Crop protection. Pests. Aphids. The nymphs and adults suck the sap. The affected leaves turn yellow, get wrinkled and distorted. The insect also exude honeydew on which fungus develop, rapidly covering the plant with sooty mold that interferes with the photosynthetic activity of the plant. Control measures. Spraying with 0.05% endosulfan or 0.02% phosphomidon or 0.03% dimethoate, methyl dimeton or thiometon control the pest effectively. Thrips. The adults and nymphs feed on leaves. They scrape the epidermis and suck the oozing sap. As a result, light brown patches appear on infested leaves. The affected leaves curl and become dry. Control measures. Spraying with 0.05% endosulfan or 0.02% phosphomidon or 0.03% dimethoate or methyl dimeton or thiometon control the pest effectively. Pod borer. Caterpillars feed on tender foliage and young pods. They make holes in the pod and feed on the developing seeds by inserting anterior half portion of their body inside the pods. Control measures. In early stages of attack, hand picking of the caterpillars and their destruction is the best method. Plowing fields after the harvest of crop would expose the pupa which would be eaten by birds. Spraying the crop with 0.05% phenolphos or phenitrohion can successfully control the pests. Spraying with HANPV, that is Helicoverpa armigera NPV at 250 larval extract per hectare also helps. Diseases. Leaf spot, angular brown or red spot with grey or brown center and reddish purple border on leaf, stalk and pods. Control measures are spray with Bordeaux mixture 5:5:50 or 0.2% Zeram. Powdery mildew. White powdery patches on leaves and other green parts later becoming dull colored and are studded with black dots. Control measures are dust the crop with finely powdered sulfur, that is 200 mesh, at 20 kg per hectare. Harvesting and yield. Harvesting of green gram requires an experienced judgment over maturity. This crop does not have uniform maturity. To avoid losses because of the shattering of pods, the crop is harvested before it is dead ripe. It is better to pick the mature pods at different time rather than to harvest the whole plant. The varieties which are quite uniform in maturity require 2 pickings. Harvested pods are dried and threshed. The yield of pure green gram crop is about 1500 to 2000 kg per hectare with about 2000 kg of straw. Summary. Green gram or mung or golden gram is also known as pachai payaru, hesaru kalu, pesara, chiru payaru in South Indian languages. Belongs to the family Fabaceae and has diploid 2n chromosome number 22. Evidences show that mung originated in South India about 3500 years ago. Green gram is cultivated in India, Burma, Ceylon, Pakistan, China, Fiji and African countries. More than 70% of world's green gram production comes from India. Mung production in the country is largely concentrated in 5 states, namely Rajasthan, Maharashtra, Andhra Pradesh, Gujarat and Bihar. These 5 states together contribute for about 70% of total mung production in the country. India is the world's largest producer as well as consumer of green gram. It produces about 1.5 to 2 million tons of mung annually from about 3 to 4 million hectares of area with an average productivity of 500 kg per hectare. Green gram output accounts for about 10 to 12% of total pulse production in the country. Green gram is a rich source of high quality protein. It contains about 24% protein. It contains amino acids such as arginine, histidine, lysine, tryptophan, etc. It is the good source of calcium, iron and phosphorus. It is rich in vitamins, thiamine, riboflavin and niacin. It is cultivated on a variety of soils from red laterite soil in South India to black cotton soil in North India and sandy soil in Rajasthan. It tolerates a wide range of pH, but the most favorable range is pH 5 to 7. Suitable climate for cultivation of green gram is the warm, humid and within temperature range of 25 to 35 degrees centigrade, with moderate rains of 80 to 100 cm well distributed during growing period of 100 days. It is also grown as fallow crop. The yield of pure green gram crop is about 1500 to 2000 kg per hectare with about 2000 kg of straw. Thank you.